This is part 3 of the rivets and bolts subsection of the structural design section of our aeronautical engineering course. At the end of part 2, we were looking at our teeter-totter, which we use as an illustration to represent 3 force vectors, F3, F1, and F4. Force vectors that represent all the incremental forces between our nail and our wood and our single shear joint with a nail nailed through a couple of 1-inch boards. Okay, we looked at how the moments balance about the fulcrum, this 50-pound guy here times this 4 feet equals the 200 pounds times 1 foot. We looked at how the moments all balance about any given point. We looked at the left point, and of course that 50 times this distance from there is 0. That 250 times its 4 balanced out with that 200 times its 5. Okay, let's look at the right point. Well, we know 50 times 5 is 250 foot-pounds, and there's 250 times 1, so they balance out. This 50 is trying to turn this thing counterclockwise about this right point. This 250 is trying to turn it clockwise about this right point. This 250 fulcrum's lifting up. Okay, no matter what point of reference we choose, even if it's a mile away, things will still balance out. Okay, here's the same teeter-totter. There's the 50-pound guy, there's 200-pound guy, there's 250-pound force from the fulcrum. And here's our reference point. We drew it a mile away from the teeter-totter just to illustrate our point. 5,280 feet from our reference point to the left end of our teeter-totter. So this 50 pounds is pulling down. It's trying to rotate this clockwise about our reference point. And it's a 50-pound force times 5,280 feet, which gives us 264,000 foot-pounds. Okay, and here's our 250-pound fulcrum. It's pushing up. It's trying to rotate all this counterclockwise about our reference point, a mile away. Well, actually a mile and 4 feet away. It's 5,280 feet to there. It's 5,284 feet to there. So 250 pounds times 5,284 feet is 1,321,000 foot-pounds. But this 200-pound weight here balances it all out. 200 feet times, well, that's 5 from there to there, so 5,280 plus 5, 5,285 feet times 200 pounds is 1,057,000 foot-pounds. And our 264,000 plus our 1,057,000 adds up to 1,321,000 foot-pounds. It all balances out, no matter where the point of reference is. Okay, some airplane handbooks use the propeller spinner as the reference point for calculating the position of the center of gravity, but most use the firewall because its position is less likely to change. Let's say somebody didn't like the spinner he had, so he put a different one on that only stuck 4 inches out in front of the propeller instead of 6. Well, that would mess up everything because the wheels are supposed to be so many inches from the front, the bags, the pilot's weight, the gas, all that. So that's why they generally choose the firewall as a reference point. Okay, now let's get back to the forces on the nail on our board. Okay, there it was. Remember this one? Back in lesson part 1 and 2. Okay, just as the weights of the 2 people sitting on a teeter-totter add up to the force of the fulcrum pushing up on the teeter-totter, F3 plus F, or this shearing force, which is equal to F1, this shearing force is pushing down on the left half of this nail because this board here is trying to pull down. So F1 is what this shearing force is, the force pulling up on that one, which is equal to the force pulling down on this one. So F1 plus F3 equals F4. just like on the teeter-totter. The 50-pound guy plus the 200-pound guy adds up to the 250-pound fulcrum. Well, those aren't necessarily the weights in this one, but we use that as an illustration. Okay, let's see if we can find the value of y. Okay, here's y from the nail head to the pivot point. Okay, we're going to find the value of y such that the distance between F3 and F4 multiplied times F3, in other words, this force times this distance will equal this force times this distance. And actually we're going to look at a value of y such that F3 times this whole distance all the way across here equals F4 times its distance from there to there. Okay. Okay, as we determined earlier, F3 is 2/3 of the way from the pivot point to the left edge. There's the pivot point, there's the left edge. It's 2/3 of the way from there to there. Or from there to there is 1/3 of that. Okay, F4 is 2/3 of the way from the pivot point to the right edge, or 1/3 of the way from the right edge back to the pivot point. From there to there is 1/3 of from there to there. Okay, let's look at the moment about a point at the right edge, right along here, of the left board, which is the left edge of the right board, where they meet. Okay, the board is 1 inch thick, 1 inch from there to there. F3 is y over 3 inches away from the left edge, because there's y from the left edge to the pivot point, and that's y over 3 from the left edge to where F3 is. F4 is 1/3 of the way from the right edge to the pivot point, so its distance is, well, from there to there would be 1 minus y, and 1/3 of that would be 1 minus y, all that divided by 3. Go ahead and put this down here. Okay, so F3 times this distance, 1, minus this distance, which is y over 3. F3 times 1 minus y over 3 equals F4 times this distance, which is this distance divided by 3. 1 minus y divided by 3. There we have 1 minus y divided by 3. Okay, so what we do here is we multiply each side of this equation by 3. So we say that times 3. Well, let's just multiply the stuff inside here times 3. We could just multiply that times 3, or we can multiply all the stuff in there times 3. Either way, we're multiplying the whole thing times 3. That's the way it is when you have something times something else, and you're multiplying by 3. So let's just multiply this part times 3. We have F3 times 1 times 3 is 3. Y over 3 times 3 is y, so 3 minus y is what all this, F3 times 3 minus y is what all this times 3 equals. Now let's multiply all this times 3. Well, we have F4 times all that times 3. Well, 1 minus y over 3 times 3 is going to be 1 minus y. Anything times 3 divided by 3 is going to be the same old anything you started out with, so F4 times 1 minus y. There we go. Okay, now we have us a ratio. We can say that divided by that is equal to that divided by that. We just divide both sides of this equation by F3, divide both sides of this equation by 1 minus y. We essentially slip this F3 under that F4, and we essentially slip this 1 minus y under that 3 minus y to give us F4 over F3 right there equals 3 minus y over 1 minus y. Okay, we also know that the ratio of F4 to F3 is proportional to the bearing surface areas and proportional to the stresses along these areas. Let's look at F4 and F3 again. Remember them here. Okay, F4 was the big one. It's a long way from there to there. F3 is the little one. It's a short way from there to there. Okay. The